There we go. So we have finished section 2.1 and we are nearly finishing section 2.2. Okay. So what I want to do right now is I want to start out by working through a couple more examples in section 2.2. And then I want to pause and then take any questions that you might have in the online homework that you've worked so far in chapter 2. Okay, perhaps you don't have questions at this point, but I really want to, before we jump into the next section, I want to be sure that I answer questions that exist. Sound good? You think so? Did you hear that? Yeah, in the hall. Sorry. God, I wish my kids were that agreeable. I'm just kidding. Okay. So we're doing more find the equation of the line. And you're going to have some online homework questions that look similar to this, which is why I'm kind of like gearing you in that. Find the equation of the line that has the same y-intercept as 5x plus 4y equals 20. And is perpendicular to the line 3x minus 2y equals 6. This is a homework type question. Okay. And by that, it's a little much for a test question. Not that it's not doable, but it's just not a very reasonable one, I don't think. So I'll give you a moment to write that down, and then we're going to talk our way through this. Tell me when you're ready. All right. So notice the first thing we want to do is find the equation of a line. So what immediately goes through my head is, okay, I need to find y equals mx plus b. In other words, specifically, I need to find the value of m and the value of b. Y'all with me this far? All right. So m is our slope, b is our y-intercept, right on. Okay, so let's talk about our y-intercept first. What information are we given about our y-intercept? Aren't we given that it has the exact same y-intercept that this line does? Y'all with me? So we can find the y-intercept of this line. Okay, there's a couple different ways that we could do it. One of them is that we can get y alone and then read off our b value. What's another way we could find our y-intercept here? By definition, your y-intercept is your value of y when x is 0. Okay? It doesn't matter which way you find it, you're going to get the same thing. That's like the beautiful thing about the consistency of mathematics as opposed to humans. Okay, so how do you want me to find it? Do you want me to set x equal to 0 and solve for y, or should I solve? Okay, so 5 times 0 plus 4y equals 20. What happens to this term? Bye-bye. So we get 4y equals 20. Divide both sides by 4. And what do we get? Yep. So at this point, we have our line to be mx plus 5. Okay. Well, next, we need to find m. What do we know about our slope? Okay, we know that our line that we're looking for is perpendicular to this line. So would you grant me if we knew the slope of this line, we could then figure out the slope of our line? Remember, perpendicular lines, technically it's called opposite reciprocals. Pragmatically speaking, it's change the sign and flip it, okay? So what we need to do is find the slope of this line. I think for me, the most natural way for me to find the slope of this line is just to get y all by its lonesome. Okay, so how would we solve this for y? Okay, we would subtract 3x from both sides. So you get negative 2y is negative 3x plus 6. Beautiful. And then we would divide both sides by negative 2. So would you agree we're going to get y equals 3/2 x minus 3? Right? Negative divided by negative is positive. 6 over negative 2 is negative 3. What is the slope of this line here? Good. So since our line is perpendicular, what is the slope of our line? Good. Change the sign and then flip it. So we have y is negative 2/3 x, and we already found our y-intercept plus 5. You okay there? Eric, you good? Cool. Okay, let's do this one. Suppose we have a car rental company. And it is 2 plans. Plan A, they charge $30 per day plus 18 cents per mile. And plan B, they charge $50 per day, but they have unlimited mileage. So what I want us to do is find the equations that model each of these plans. And then from there, what we're going to do is determine the number of miles that would make plan B cheaper. All right, so plan A, if we don't drive very far, would you grant me that's a cheaper plan? Okay. But if we're going to drive a ton each day, at a certain point, plan B is going to be a lot more cost effective, right? So if you're just renting something to just drive around in town, this is probably your better deal. But if you're renting something to take off to southern Utah, you'd probably want to go with this route. Okay. So first thing we want to do is find the equations that model each of these plans. I'm going to say, do you agree that at least in plan A, our cost is going to depend upon how many miles we drive? Okay, so I'm going to let X represent the number of miles driven. So plan A. Well, again, this is going to be a linear function, mx plus b. What is my slope? In other words, what changes? Number of miles. So wouldn't that be 0.18x? And then what's my fixed cost for not even driving anywhere? 30. Okay, notice you don't put you put 0.18 and 30. If you just put 18 here, you sure better express this in cents as well. You need to be consistent with your units. Okay, how about plan B? And let's just assume it's for one day. It's just a constant $50. Okay, and these are our costs per day. Any questions on finding the equations? All right, so how would we figure out the number of miles we would need to go in order to make plan B be a better value? It's where the lines intersect. Okay, but I don't feel like graphing these lines. Okay, so one way we could do it is we could say, well, we could find where plan A is equal to plan B. And then anything beyond that wouldn't be cheaper. Okay, well, plan A, the cost per day is 0.18x plus 30. And we want to know, when would that be about the same as plan B, which is 50? Can we solve this? Yep. What would be my first step? You got it. So we'll subtract 30 from both sides. You get 0.18x equals 20. Divide both sides by 0.18. And you're going to get x to be 111.1 repeating. I did the computations beforehand.
Is that line rule 0.1?
Yeah. All right. So if we drive 111.1111111 miles, they're going to cost the same. So let's go to the next whole number. At what point will plan B be cheaper? 112 miles and beyond. Are you thrilled? I know. All right, any questions? So let me exit full screen. Let me go into the MyOpenMath. I gotta share it. Okay.
That would work the same for the variable in both lines, right?
Yes. Yes. So 2.1, hopefully you're all aware, is due next Wednesday by midnight. 2.2 is going to be due next Friday by midnight. Cool. So before I exit this page, I want to ask, I first want to just remind you all that if you need to watch like little videos, they're here, you know, aside from the videos connected to homework, and similarly here as well. Does anyone want me to go through anything in either section 2.1 or 2.2 at this time? Okay, so I want you to just relax this weekend and have a really chill weekend, but it would be a good idea if you start working in the online homework. So one of the things that I want to comment on is we are going to be doing, you'll see that, here, let me show you student perspective. There we go. So we've done 2.1 and 2.2. We just have 2.3 and 2.4, and then we're done with chapter 2. Okay. 2.3, we're going to take a little bit of time. That's word problems. We've already sort of walked into those a little bit. We're just going to dive in a little bit deeper. And then you'll have some homework. 2.4, I'm going to talk about. You're not tested on it. You have like, I think 5 homework questions. It's important, but it's nothing that we really delve into in this class. It's more just, I want to make you aware of it. You can take Math 115 and really dive into linear approximation. Okay. But once we finish chapter 2, we're going to have a quiz. Okay. This was in my email that I sent to the class. Because our next test is not until we're done with chapter 4, and we're going to be in chapter 4 for a period of time. That's probably our most substantial chapter. So be prepared that there's going to be an upcoming quiz in here. When we're done with chapter 2, it'll just cover 2.1, 2.2, and 2.3. Okay, yes. It's a written one because then you get partial credit. Yeah. Exponential and logarithmic functions. Are you psyched?
Yeah.
Yeah. Well, hopefully I'll be able to make it a little bit better. I don't claim I'll convert you, but I'll do my best to make them be a little less painful. You know how we've talked about inverse functions, right? So if a function does something and inverse undoes it or brings it back to where you started, the whole reason for log functions is because they're an inverse of an exponential. So, but they look funky, right? Because you have all the different notation for it. But we'll ease into it. That's my hope. Okay. All right. So why don't we jump into section 2.3? And what I'm going to do is just work through several examples. So it's not really any new material here. Okay, we've already found how to graph lines. We've already found how to get the equations of lines and interpret all of that. What we're going to do now is just a bunch of word problems that involve lines. Okay, so let me just show you how a few of them go. Suppose in 2003, I can spell. The population was 1,431 people. And suppose in 2007, the population was 2,134. Oh, fun. Not a wide variety of digits. And let's assume that this is not reality and that the population grows linearly. In general, population grows exponentially. Thus our 8 billion people and counting. All right, I'm just going to ask you some various questions And they're not trick questions. I just want to, kind of present all of the different ways of looking at this. Okay. So over this time period, how much did our population grow? Good. How'd you get that? Right, but you subtracted, right? We're looking at the change in population, right? So we just want to know how much it grew by. Notice we're not asking a rate. We can say, well, 2,134 minus 1,431 is by 703 people. Thank you, calculators. You with me there? Okay. How long did it take for this population change? Good. 4 years. Y'all with me there? Did you use a calculator? I'm just kidding. No, I just like joking around because when classes are too serious, then they're no fun anymore. Okay, what if I asked you this? What is the average population growth per year? Beautiful. Okay. Yeah, I would too. Okay. Notice here we're finding the slope. Aren't we looking at the change in population over the change in time? So we have 703 divided by 4, which is 175.75 people per year. All right. So suppose we wanted to write this as a linear equation. And I'm going to let T represent the number of years after 2000. And I'll call my function P of T, and that's the population. So given that I want to find the equation of a line, I'm going to write it as MT plus B because I'm using T as my variable right now. If you write an X, the online homework will have problems, but I won't. Okay. What did we find already? We found M. We found our rate of change. Okay. Do we know B? Not yet. May I ask you a question? Given the fact that T represents the number of years after 2000, once we find the value of B, what are we finding? Yep, the starting population. In other words, the population in the year 2000. Okay, so you don't want to just plug in one of these values for B because that B is our starting point, which we're saying is in the year 2000. So how can we find B? Okay, good. What we can do is we can take one of these ordered pairs and plug it in. Do you agree that we could write each of these as ordered pairs TP? So what would be my first ordered pair? Be careful. If T is the number of years after 2000, wouldn't this just be 3? And then 1,431? And then what would my next ordered pair be? 7 and then 2134. Are there any questions how I got those ordered pairs? So what I'm going to do is I'm randomly just going to take one of these ordered pairs and plug it in and solve for B. I'll just take this one for really no good reason. So I know my population is 1,431 when T is 3. So we get 1431. If you multiply this, I did the computations beforehand. I'm not doing them in my head. Just don't want to. And we can then subtract both sides by 527.25. And what do we get for B? You get 903.75. So here is the equation that models this population. So then if I asked you, which I've already given away, what is the population in the year 2000? What are you going to tell me? 903.75. Yeah, so then we ask ourselves, what the heck does that mean? It means that a baby was 3/4 of the way out or some such thing. I don't know. Okay. What if I want us now, because we just can't be done with this yet, to predict the population? I don't know, how about in 2025? You got it. Good. So P of T is 175.75 T plus 903.75. And since we want to know the population, we're looking for P, we've got to figure out what T is. And just like you mentioned, since T represents the number of years after 2000, what we're computing is P of 25. And we're going to get a half a person. Do you like these word problems so far?
Yes.
Are there questions? Is this a lot? Is this okay so far? Ross, what do you think? Cool. All right. Let's do another one. So suppose I tell you the following. Suppose I tell you that there's some phone plan, okay? And with most phone plans, or like historically with phone plans, if we wanted to write them as a line, typically your B is your fixed cost, right? So it's kind of like renting a car. When you have a phone plan, you have your monthly fixed cost. And then it used to be the case that you would then pay by how much data you use. Okay. So suppose I tell you that this phone plan says if you use 20 megabytes of data, your total cost is $11.20. And if you use 130 megabytes of data, boy, I wish things were this cheap. And suppose I let X represent the number of megabytes of data. First thing I want us to do is find the linear function that models this phone plan. Now notice here, we're not given our slope, we're not given our y-intercept. But what are we given? We are given 2 points on this line, right? What is one of my ordered pairs? Good, 20 and then 11.2. And what's the other ordered pair? I gotta put some, sorry. You don't have to put those zeros, but when I'm talking money, I'm. All right. Can I find the slope of this line?
And
How would I do it? Where does that go? It's the change in Y values over the change in X values. Yep. 1780 minus 1120 divided by 130 minus 20. It's the change in Y values over the change in X values. So we get 6.6 over 110, which is 0.06. You with me there? Okay, how would we interpret this slope? Let's interpret it. Well, let's think about the units. What are the units in my numerator? Isn't that money? Dollars per megabytes. So our cost is $0.06 per megabyte. In other words, this plan charges us 6 cents per megabyte. Any questions on the interpreting? All right. Well, we thus far have y equals 0.06x plus b. Why don't we now take an ordered pair and plug it in? So I'll just take the smaller ordered pair just because I like dealing with smaller numbers. So I have 11.2 is 0.06 times 20 plus b. So 11.2 is what, 1.2 plus b? This is sweet. What do we get b to be? 10. How would we interpret our y-intercept then in the context of this question? Yep, it's a $10 flat fee, or you could say it's $10 when using 0 megabytes of data. Cool. Should we do one more for today? We're here, we might as well, right? What else would we rather do on a beautiful Friday afternoon? And then I have one, we'll go through one more, and then I have one announcement, and then we'll call it good for today. Okay. So let us do this. Suppose in the year 2010, the oil reserves held 16 billion cubic feet. And suppose these oil reserves are depleted by 2.1 billion cubic feet per year. I'm going to let T represent the number of years since 2010. I love doing that. And you might be what? Saying number of years since 2010? No, I love defining my input to be the number of years since a value I already have, because then what do I already know in my equation? I know my y-intercept. Okay, so what I want us to find is the equation of our reserves. Then what we're going to do is find how much we have in reserves in 2015. And then just when will it be depleted? All right. Well, R of T is MT plus B. And which one do we have? Do we know our slope? Do we know our y-intercept? We know our slope, and I claim we know our y-intercept, right? What's our slope? How much is this changing per year? 2.1. But since it's going away, what do I need? I need negative 2.1. Now I'm just going to keep my units in billions because I sure as heck don't want to put all those zeros. And do I know the amount of reserves I have initially? Yeah, what is that? It's 16, right? If I let T be the number of years since 2010, then my initial value is going to be 16. You cool there? Okay. So what if I want to find the reserves in 2015? Well, again, I'm looking for the reserves. I need to figure out what is my T value I'm plugging in. And it is 5, right? Because again, T is the number of years since 2010, and we are 5 years later. And if you do this computation, you're going to get 5.5 billion cubic feet. Notice it makes sense that it's decreased because we're using it up. Any questions this far? You okay? Cool. Ah, yeah. Yeah, you always got to notice how your T is defined. So now what we want to do is the last part. When will it be depleted? Notice we're asking when. What does that mean that we're looking for? The T value. Okay, well, we want to find T, so we better know R. What is R if it's depleted? It's nothing. Does that make sense? Okay, can we solve this? What would we do first? Okay, we could subtract 16 divided by negative 2.1. So we're gonna get T to be about 7.6. I'm just gonna round up to 8. Is my answer 8?
Or no, it's gonna be 2018.
Good. Notice I want to know when. Well, 8 years after 2010. So during the year 2018. Is that okay? Do you like these? Thumbs up, thumbs down? You don't have to like them. I mean, seriously.
Move all in one spot instead of moving them.
Yeah, we like to do those things. So we'll get out a bit early today, which isn't a bad deal for a Friday. But what I'm going to say is that let's have our quiz on chapter 2 be next Friday. Week from today. Or we could do it the following Monday. Does anyone have a preference whether we have the quiz on Friday or a Monday? Yeah, I mean, it's sort of like if you have it on Friday, then you don't have to worry about math over the weekend. If you have it on Monday, then you don't have to worry, but it means it's hanging over your head. All right, so unless we fall, back a little bit, let's plan that the quiz is going to be next Friday. Honestly, it will only take me a moment to talk about 2.4, and the quiz is just on 2.1 through 2.3. All right, my friends, I hope you have an awesome weekend.